Hi, thank you so much. I think I'm going to end the show by talking about something happy, about how wonderful it was to be a child. No responsibilities, no bills. You've literally never ever heard of Brexit, so everything's fine. And but the best thing of it all is clearly the magic. There's magic out there. But I'd argue that there's magic in everything that we do as scientists. Because everything we don't understand is magical. We don't know how life arose on this planet, let alone gave rise to Donald Trump. We certainly don't know how the physical network of neurons in our brain gives rise to the ephemeral feeling of consciousness that we all have. But the thing that I'm most fascinated by is an even larger network that spans entire continents. I'm talking about the mycorrhizal network of fungi that exists below our feet in the soil that supports all life on Earth. Because the vast majority of plants on our planet need these fungi to access water and nutrients from the soil. So they're literally necessary for those plants to survive. But they also do something much cooler. They connect all of those plants underneath the soil. And by forming this huge interconnected network, they govern the distribution and flow of nutrients throughout ecosystems. And they can even support unhealthy individuals and keep the ecosystem resilient. In our lab, I'm interested in understanding how we can manage natural ecosystems in the fight against global change. And we're realizing that one of the keys to being able to do this might actually be understanding that immense magical mycorrhizal network. So for the last few years, we've collected about 33 million observations of mycorrhizal status all over the globe. And using artificial intelligence and machine learning approaches, we've actually been able to map that entire mycorrhizal network. Just like a sort of MRI scan of the brain showing you how the brain functions, this global map can help us to understand how natural ecosystems function. So we see in tropical forests, soils are dominated by these tiny arbuscular mycorrhizal fungi, which promote really rapid tree growth. Whereas in the higher latitudes, 66% of the world's trees are connected with their neighbors through massive networks of ectomycorrhizal fungi. And these grow really, really slowly, and they're very responsive to changes in temperature and moisture, so these ecosystems are particularly vulnerable to global change. Now we've got this global understanding, the UN's Trillion Tree campaign is actually using this information to guide targeted restoration of forests around the world. In Costa Rica, they're aiming to plant trees that actively promote arbuscular mycorrhizal fungi. Whereas in northern Canada, they're doing a completely different approach. Instead, they're preserving and protecting the soil from tillage and disturbance to promote the growth of these ectomycorrhizal networks. We're only recently starting to understand the immense power of the global forest system in its ability to draw down carbon from the atmosphere. It's undoubtedly one of our strongest tools in the fight against climate change, but managing effectively necessitates that we understand this magical network that supports the whole thing. With limited time and resources to address climate change, this global scale understanding could be critical if we're going to have an effective strategy. Thank you very much.